Assalamualaikum and good day to everyone. So, as we know that we have been given a task to make a project that depends on the title that given to each group. So, for our group, we are given the title Cyclic Code. So the cyclic code is actually in coding theory, a cyclic code is a block code where the circular shifts of each code words gives another word that belongs to the code. There are error correction codes that have algebraic properties that is convenient for efficient error detection and correction. Okay, so before we go any further, let me introduce myself. My name is Muhammad Amir bin Roli and I'm from group 2 and I am group with Faris Iman, Aiman Tulus, Shamin Ashraf and Siti Nur Shafika. So as what we researched for, we have found that cyclic codes was divided into two parts. So the first part is the generation, which mean the encoding, and the next part the detection, means the decoding. The generation encoding is actually divided into three parts, and the detection decoding is divided into two parts. As we can see in the picture given, so the generation encoding is divided into three parts, which is the first one is non-systematic, the second one is systematic, and the last one is cyclic encodes shift register flip-flop. So for the non-systematic is divided into two. It's actually not divided, but it's they have two type of method. So the first one is multiplication method and the second one is the generator metric method. And for the systematic also have two method. The first one is a division method and also have a generator metric method. So as we can see for the detection decoding, so the syndrome decoding error pattern and syndrome calculator shift register flip-flop is under the detection decoding. Okay, let me explain about the cyclic codes. Okay, cyclic codes are special linear block codes with one extra property. In a cyclic code, if a code word is cyclically shifted, means it was rotated, the result is another code word. For example, if 1011 000 is a code word and we cyclically left shift, then it will be 01100001 is also a code word. Okay, as I mentioned before, there were too many subtopic that have under the cyclic codes. So in this video, we will discover about the basic of the cyclic code and its properties. We will give the basic and properties with the example. So how to know the basic? So the cyclic codes are sub part of linear block codes. Then it follows following properties, which include two properties. The first one is linearity property, and the second one cyclic shifting. Okay, so what have under the linearity property? Okay, for the linearity property, if we have to code words ci plus cj, ci and cj, then cp is equal ci plus cj, where cp should be a code word. So for the cyclic shifting, the code word is equal to c1, then c2, then c3 and others. So for the cyclic shifting also, after shifting left or right any number of bits, the resultant code should be a code word. Okay, the rule is if code words follow above two property, then only that codes will be cyclic codes. So that was for the basic part of the cyclic code. So let's have a look for the example. Okay, the first one I will show this one, 0 0 0, then 0 1 1 0, then 1 0 0 1, then 1 1 1 1. So let's see if the bit is the cyclic codes or not. So firstly we must check the property of linearity. So the bit is starting with 0 0 0 0. So for check the property, the 0 0 0 bits is doesn't count because it doesn't have a value. So we must use the second and the next one. So as we can see, the first one, okay, 0 1 1 0 plus 1 0 0 1 is equal 0 plus 1 is equal 1, 1 plus 0 is equal 1, 1 plus 0 is equal 1, 0 plus 1 is equal 1. So for the next is 0 plus 1 is equal 1, 1 plus 1 is equal 0, and 1 plus 1 is equal 0, and 0 plus 1 is equal 1. Then for the last one is 1 plus 1 is equal 0, and 0 plus 1 is equal 1, 0 plus 1 is equal 1, and 1 plus 1 is equal 0. So all the resultant is follow the property of linearity. So after the first part is achieved, then we must check the property of shifting. Okay, to check the property of shifting, as we can see here, okay, 0 1 1 0, when we shift it will be like 0 0 1 1. So for this part is actually not a code word. So all the resultant is actually not a cyclic codes. So this example is not a cyclic code. So let's take a look for another example. Okay, for the next example, as we can see here, okay, 0 0 0 0 0 1 0 1, 1 0 1 0, and 1 1 1 1. So let's check whether the bits is a cyclic code or not. So first one is same, we must check the property of linearity. So as the first one, we can calculate like this. Okay, 0 1 0 1 plus 1 0 1 0. Okay, 0 plus 1 is equal 1, 1 plus 0 is equal 1, 0 plus 1 is equal 1, 1 plus 0 is equal 1. So for the next one is 0 1 0 1 plus 1 1 1 1. So 0 plus 1 is equal 1, 1 plus 1 is equal 0, 0 plus 1 is equal 1, 1 plus 1 is equal 0. So for the last one is 1 0 1 0 plus 1 1 1 1. Okay, 1 plus 1 is equal 0, 0 plus 1 is equal 1, 1 plus 1 is equal 0, 0 plus 1 is equal 1. So all the resultant codes is actually follow the property of linearity. So next, also same, we need to check the shifting property. Okay, for the shifting property, so as you can see here, we take the 0 1 0 1, and when it shifts, it will be like 1 0 1 0, and yes, we got the 1 0 1 0 in the bit, so it will declare as a code word. So the following result code is shifting property. So it was follow the shifting property, and that's mean the result code above was a cyclic code. Okay, so that's all for the example, and also for the cyclic code in this video. So as a conclusion, we can see that the cyclic codes are determined by the linearity and shifting property. So as long as the result code is same in the bit code, so it was declared as a cyclic code.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Ahmad Tulus. Okay, I'm gonna explain about the non-systematic cycling code. Okay, the non-systematic cycling code is the output code word is generated using polynomial multiplication. Okay, the cyclic code for non-systematic code word, the equation is Cx equal to Mx multiplied by Gx. Okay, where the Cx is equal to the code word polynomial, while the Mx is equal to message polynomial, and Gx is equal to generator polynomial. Okay, here's some example for the code that we given. Okay, the code is 1011. Okay, and the 1 is same as the x power of 0, and this 1 is equals to same as x is x power of 1, and 0 x power of 2, 1 x power of 3. Okay, we next we can assume that x power of 3 is multiplied by 1 plus x power of 2 multiplied by 0 plus x power of 1 multiplied by 1 and plus x power of 0 multiplied by 1. So that is given the x power of, so the solution is x power of 3 plus x plus 1. Okay, here another example of the non-systematic cyclic code. Okay, construct non-systematic cyclic code. Here the given message and generate cyclic code. Okay, so the generate cyclic code is Gx equals to x power of 3 plus x power of 2 plus 1, with the message is 1010. Okay, here the message that is given 1010. So we need to change to message polynomial. So the mx is equals to x3 plus x. Okay, and then the generation polynomial gx equals to x3 plus x2 plus 1 that is given in the question. Okay, then we need to solve the equation. So the code work polynomial equal to message polynomial and generation polynomial. Okay, so that is given. So we take from here the message polynomial x power of 3 plus x multiple the generation polynomial x power of 3 plus x power of 2 plus 1. So you can get the x power of 6 plus x power of 5 plus x power of 3 plus x power of 4 plus x power of 3 and plus x. So we can cancel out the same equation here, x power of 3 and x power of 3 in here. So next is, so we can get x power of 6 plus x power of 5 plus x power of 4 and plus x. So the code that we can get from the code work polynomial is 0 1 0 0 1 1 1. Okay, that's all the example from the non-systematic cyclic code. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syamil Ashraf bin Nordin from Group 2. So, for the systematic cyclic codes, polynomial multiplication encoding for cyclic linear codes is easy. Unfortunately, the codes obtained are in most cases not systematic. Systematic cyclic code can be obtained through a procedure that is only slightly more complicated than the polynomial multiplication procedure. So basically, the systematic encoding has 3 steps. The first step is multiply the message polynomial, which is mx and x to the power n minus k. Next, we divide the result from first step by the generator of polynomial, which is gx, and the remainder is dx. And lastly, we set cx equals to x n minus k mx minus the remainder. So, code word for systematic code word is given by cx equals to x power of n minus k mx plus px, where px is the remainder of x to the power n minus k mx divided by gx. Cx is code word polynomial, mx is message polynomial, and gx is generator polynomial. Lastly, c equals to message and parity. So for the first example is construct a systematic cyclic code 7-4 using generator polynomial gx x power of 3 plus x power of 2 plus 1 with message 1010. 7-4 code is n equals to 7 and k equals to 4. For the message is 1010, which is 0 for x power 0, 1 for x power 1, and 0 x square, 1 x cube. Then we go through the equation, which is cx equals to x power of n minus k mx plus px. So px is remainder of x power of n minus k mx divided by gx. Then we substitute the equation, which n minus k is x cube, mx is x cube plus x, and gx is x cube plus x square plus 1. Then remainder is, then px is remainder of x power of 6 plus x power 4 divided by x power of cube plus x square plus 1. Then remainder is 1. The division is 1. Then we go to the cx, which is x n minus k mx plus px. Then this the equation we just substitute from the early, which is x cube plus x plus 1. 1 is the remainder, which is px. Then we get the x power of 6 plus x power of 4 plus 1. Then final answer is C10100001, which is x power of 0. We get for the answer, which is 1, x power of 1, 0, x power of 2, 0, x power of 2, 0, x power of 4 is in the answer, which is 1, x power of 5, 0, x power of 6, 1. That's all for the systematic cyclic code.
Hi, I will continue on the decoding of the cyclic code. Okay, the decoding of the cyclic code consists of 3 steps, which is syndrome computation, association of the syndrome to an error pattern, and also error correction. So now I will show you the decoding operation of correcting the error. As you can see here, it is the general decoder for an NK cyclic code. It consists of 3 major parts, which is 1. A syndrome register, 2. An error pattern detector, and the third one is a buffer register to hold the receive vector. So to remove the effect of an error digit on the syndrome, we simply feed the error digit into the shift register from the left end through an exclusive OR gate. So the decoding operation consists of 5 steps. Step 1. The syndrome is formed by shifting the entire receive vector into the syndrome register, and at the same time, the receive vector is stored into the buffer register. So step 2. The syndrome is read into the detector and is tested for the corresponding error pattern, and then the detector is a combinational logic circuit where its output is 1 if the syndrome in the syndrome register correspond to a correctable error pattern with an error at the highest order position at power n minus 1. So if 1 appear at the output of the detector, the receive symbol in the rightmost stage of the buffer register is assumed to be error and must be corrected. And if 0 appear at the output of the detector, the receive symbol at the rightmost stage of the buffer register is assumed to be correct and no correction is necessary. Okay, step 3. The first receive symbol is read out of the buffer. If the first receive symbol is detected to be an error symbol, it is corrected by the output of the detector. The output of the detector is fed back to the syndrome register to modify the syndrome. So this result is in a new syndrome which correspond to the alter receive vector shifted 1 place to the right. And the next step is step 4. The new syndrome form in the step 3 is used to detect whether or not the second receive symbol is an error symbol. Then the decoder repeat step 2 and step 3. And for step 5, the decoder decodes the receive vector symbol by symbol in the manner outlined above until the entire receive vector is read out of the buffer register. And last but not least, this decoder is known as magic decoder.